Did you know that light can turn into a liquid if you cool it enough? At absolute zero, the coldest temperature possible in the universe, some really weird things can happen, and light changing into a state of matter that flows more like water is one of them. So how is this all possible, and what else would happen in the universe at the temperature of absolute zero? While space is really, really cold, as far as we know, there isn't a single place in the entire universe where absolute zero naturally occurs. But here on Earth, we've attempted to do just that, and we have gotten extremely close. Now, you might be asking, how cold is absolute zero really? So think about the coldest thing that you possibly can. Maybe you're thinking of something as cold as like Antarctica. Anything that you're imagining right now is absolutely nothing compared to absolute zero. We're talking about 0 degrees Kelvin, which is negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. The simplest way to think about absolute zero is the complete absence of thermal energy. That means to achieve absolute zero, everything has to stop moving, including atoms. But according to everything that we know about physics, specifically quantum physics, there is absolutely no way to stop atoms from moving or vibrating that we know of. In order to achieve absolute zero, you'd effectively need to continue to remove any heat from a system until there is zero thermal energy left over. However, the very act of removing the heat uses energy to do so, creating its own thermal energy, so you kind of get stuck in this infinite loop that will never truly allow you to reach absolute zero. But just because we can't reach absolute zero currently doesn't mean that we don't know exactly what would happen in the universe at that temperature. One of the things that would happen is light particles would behave in an extremely odd way. As you cool a collection of light particles enough, their wavelengths will stretch further and further apart until eventually their wavelengths will match up. This means that none of the light particles are colliding with one another, and light itself would form a completely different state of matter. This state of matter is called a Bose-Einstein condensate. Now, while light particles in a Bose-Einstein condensate state of matter don't turn into literal water, it's just an analogy to express how light would behave and how it would flow like water at absolute zero. But that's not the only strange thing that would happen in the universe at absolute zero. Let's talk about superfluids. And no, I'm not talking about superfluids like that. I'm talking about superfluids that are so cold that they don't have any friction or viscosity. And the cool thing is we can actually make these superfluids before you get to absolute zero. And one of the things we can do that with is helium. Normally, you think of helium as the thing that makes balloons float,
and your voice get really, really squeaky.
But if you cool helium to negative 270 degrees Celsius, which is 2 Kelvin, it will become a superfluid. And not only do we know that this can happen in theory, we've done this in practice. During these experiments, helium would flow up and out of any bowl, container, or cup that it was in. Because all the liquid helium atoms are acting all in unison and not bumping into one another, if you push the liquid helium in one direction, say towards a wall of the container, it would just continue and go up and out of the container. There's no friction or anything to stop it from continuing its motion. And not only that, it would just kind of slip past everything. So not only would it go up and out the container, but it would also go through the walls of the container as well. And probably one of the craziest things is that if you had a liquid helium superfluid and then just simply stirred it, as long as it stayed cold enough to remain a superfluid, it would continue to stir at the same rate forever. It would never stop stirring. Alright, so that's not the only weird thing that happens at absolute zero. Electricity also acts in weird ways and in a way acts a lot like a superfluid. It can become a superconductor. Much like the superfluid, a superconductor has absolutely zero resistance. At, normal temperatures, let's say in your house, when you run electricity through those copper wires in order to turn on a light bulb, the electricity bounces around within the copper wire. It has resistance. This results in both energy being lost in the electricity and the copper heating up. When electricity is a superconductor, it will flow through copper with absolutely zero resistance, meaning that there is zero energy lost in the electricity and zero heat gained by whatever the electricity is passing through. That would mean that you would have perfect efficiency with the transfer of energy. And if we could somehow control superconductors, we can make a lot of really cool things happen, like batteries that never degrade and better quantum computers. And just to sort of bring this all together, there is a theory out there that suggests that the fabric of space-time itself might be a superfluid. And if we were somehow able to figure out how that's true, we'd instantly unlock all the secrets of the universe.